Today we're going to look at different data representations. So let's just go ahead and get right into it. Number one, the students' scores on a math test are shown on the following frequency table. So what a frequency table tells you is, depending on a score, for example, if I wanted to know how many students got a 22 on this test, that tells you that 3 students got a 22. So instead of writing out all the data one by one, it kind of summarizes your data by its frequency. Anyways, how many students scored below 21? So if you scored below 21, let me highlight those values. Below 21 would include 20, 19, 18, 17, 16. So the sum of all those frequencies would be my answer. So 4 plus 1 plus 2 plus 3 plus 3, which is 13. Number 2. The table gives data on the number of tickets sold during 3 days at a movie theater. So find the total number of tickets sold on Saturday. So it doesn't ask if we're specifically talking about the adults or the seniors or the children. It says the total number. So we're only looking at Saturday on my frequency table. And the table breaks that up into the frequency of adults, seniors, and children. But that's all part of Saturday, right? So the sum of these 3 numbers is the answer. So we go ahead and load up our Desmos and let's find the sum. 156 plus 98 plus 185. So 439 tickets were sold on Saturday. This question says to find the total number of tickets sold to seniors on all 3 days. So now we don't care about which day. We're going to take the sum of all the days, but only the senior tickets. So in this case, it would be 34 plus 98 plus 102. So now we're taking a horizontal sum. In the previous problem, we added a vertical sum because we were just looking at a different part of the table. I'll leave that for you to take the sum. Just go ahead and use a calculator if necessary. All right, number 4. The scores of a recent quiz on Mrs. On's class are given in the stem and leaf plot. So this table looks really weird because on the left we have 1, 2, 5, 7, 8, 9. And on the right we have all these extra digits. So what a stem and leaf plot does is it's another way to summarize data. Instead of writing out every single data value, it kind of summarizes it. But let me write out the long version of what this table means. So this first row here, the 1 and the 7, this first column tells us the tens place of our score, and then the next column tells us the ones place. This score would be a 17. So the 1 and the 7 means there was a 17. Someone scored a 17. Now, this next row has a 2 on the left, which means we're scoring in the 20s now, but then there's a 0 and a 4, which means someone scored a 20 and someone scored a 24. And I'll do one more row just to illustrate. This row here shows we start with a 5, so now we're in the 50s. So someone scored a 55, a 55, and a 56. That's why there's 3 digits. 5, 5, 6 means 55, 55, and 56. And all it asks is, what is the mode score of the quizzes? So the mode means the most frequent value. So if you look at the table and you find any repeated values, that's a candidate for the mode, right? So the only digit I see repeated is right here. And that would actually be these 2 values here. So that means the mode of this data set is 55. Okay, what is the median score? So this question is a little annoying because we have our stem and leaf plot, which kind of organize the data for us. But now we're just going to go ahead and write it all out. And this is just for clarity. I mean, you might not need to do this, but it might be useful to someone out there. So I'm going to go ahead and just write out all the data. Okay, there's all the data. The median should be right in the middle. So what that means is there should be the same number of scores on the left and on the right, right? 50% of your data is less than, 50% of your data is greater than. So let's count how many scores are in this data set. So I'm just going to count the ones place column over here on the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 14 scores. So if there's 14 scores, half of that would be 7. So if I count 7 in, let's see here. 7 on the left. 7 on the right. And if you recall, either from learning it or my previous video on covering statistics, if there's no median value, right, there's no value in between these. So in our data set, there is no median. So we have to calculate one. So to find the median in this case, you take the average or the mean. So we have to take the mean of 71 and 72. So to calculate a mean, you just add and divide by how many values you're adding to find the mean. So the mean of 2 numbers is you take the sum and divide by 2, and that would be 71.5. And just to make sure it's clear and understand why that's the value, 71.5 is not a value in our data set, but to call that our median, what it successfully does is if our median is 71.5, exactly half of the data, 7 scores, are less than that, And exactly half our data, 7 scores again, is greater than 71.5. So to find the range, it's just the maximum value minus the minimum value of your data. So pretty simple here. The maximum is right here. So that's a 99. Someone scored a 99. And the minimum is the lowest in our table. So a 7 at the beginning of the table counts as a 17. So the range of our data is 82. All right, what is the mean of the quizzes? So I'm going to go ahead and steal my values from before. So to find a mean, we're just going to add up all the values and divide by the number of values. So from the previous question, I did find out that there are 14 scores. So we are going to divide by 14. I'm going to go ahead and just open up Desmos and start typing in the sum as I go. So I'm going to hit the slash key to start a fraction, right? So if you hit the slash key, you get a fraction bar and you can toggle between. I know I'm going to divide by 14 scores, so 14 on the bottom. All right, here I go, 17 plus, and I'll just go ahead and add the rest here. And hopefully I didn't make a mistake, but according to what I have here, my average or mean value is 65.07, so I'll round that to 65.1 if I round it to the 10th place. Okay, number 8 here has a histogram, and the question we have is, what is the total number of students in the class? So a histogram gives you a range of values, and then it tells you the frequency of people that exist in that data set. We're just going to basically count the heights of each of these bars because that's the frequency of each bar. The frequency tells you how many data values exist in that bar. So 160 to 169, there's 2 in there. The next bar has 4. The next bar has 5. The next one has 4. And the last bar has 1. So if you take the sum of these values, that's how many people were counted in the data set. So 2 plus 4 plus 5 plus 4 plus 1 would be 16. How many students are less than 190 centimeters in height? So less than 190 means you can't be in the data set that's over 190. So this dividing line here would tell us which bars we're considering less than, right? Less than 190. So only the bars less than that red line. So that would be 2, 4, 5. So that would be 11 students, right? 11 students are less than that line there. How many students are taller than 169 centimeters? So in this bar here, the range ends at 169. So if you're taller than this, you're all the bars after this bar. So that would be a frequency of 4 plus 5 plus 4 plus 1, which would be 14 students. Okay, give a possible height for the tallest student in the class. So this is kind of an ambiguous question, but hopefully it makes sense. We know that when you go to this last bar here, this is where the tallest kid in the class is recorded, right? And the histogram doesn't give a specific value for this height. We know their height is between 200 and 209 centimeters. So any value you choose between or including 200 and 209 would be fine. So I'll just go ahead and say 207. Any value from 200 to 209 would be acceptable. The histogram does not explicitly give the value in that bar. Okay, lastly, give a possible median height for the data given. So median would be the middle of our data if it was all written out. But in a histogram, we don't have any data written out. So this is a very strange question. But from a previous question, we did ask how many students there were. There are 16 students in the class. So how can I use this information? Well, if there's 16 students, half would be below the median and half would be above the median. So that means half and half, there should be 8 and 8 on either side of the median. So let me count my bars again. There's 2, 4, 5, 4, 1. So think about this. If there's 16 students, half would be 8. So if I went 8 students from the left, 2 plus 4 is 6. 2 more students would land me somewhere in this bar. Right? So if you count 8 students from the left or the beginning of your data, or if you count 8 students from the right of your data at the end of your data, and you go 8 students in from either way, your median value has to be somewhere in this bar. Again, kind of an ambiguous question, but it says give a possible median height. It could be any value from 180 to 189 or including them. So I'll just say 185. Because I know 185 centimeters is in that bar on my histogram, Any value in that range on that histogram bar is acceptable. All right, well, I hope that helped with looking at these different data representations.